All right, lesson 1 for today is about a couple of new symbols that we're going to use when talking about sets. One thing to clarify though is that in your notes yesterday there was an error, which is that this n sub 0 and the n, I think, were swapped. I put them in the wrong places. N sub 0 is the set of all natural numbers and 0, and n is just the set of all positive numbers. So this set n is actually smaller than n sub 0. N sub 0 should be on the outside. Thanks to Victor for pointing that out. Okay, so next, the new symbols that you guys should know. This is one. It is a U, a regular capital U, and it means union. It's also known as the term OR, and I'll explain why in just a minute. So the union of two sets is the equivalent of a quote-unquote superset made up of both sets. It's two different sets combined together in one. Visually, as an example, the natural numbers union the irrational numbers would look like this. You would take the set of natural numbers, you would take the set of irrational numbers, and everything that's highlighted in yellow here, that whole thing is the equivalent of one set, which is denoted by this entire combination of symbols, N union Q apostrophe. That thing together, that's the set represented by this expression. So if I were to write N union Q apostrophe, it refers to this double set. That comes up on page 3 in your handout with a bunch of statements that are asking you if they're true or false that look something like this. So when you are determining if n, the natural numbers, are a subset of this new set, what you could do is you could figure out visually what this set means and then determine if n is located inside that set. That's one way to do it. The other way, and the reason that OR comes up, is because for this statement to be true, the n has to be a subset of one part or the other part. If it's a part of one, if it's a subset of one, that is good enough. It has to be one or the other. So you can go through and check both statements. Is n a subset of z? Yeah. Is n a subset of q prime, the irrational numbers? No. But because this one was a yes, because n is a subset of z, that's good enough. 1 is good enough when you're talking about union. That's not true for all symbols, but it is true for this one. As a new example, or another example, is root 3, the number, an element of this set, n union q. The natural numbers unioned with the rational numbers. So again, in terms of using this OR definition, I could figure out, is root 3 an element of n, or is root 3 an element of q? And if I wanted to look visually, I would look to see at what the set looks like when n and q are put together, and check to see if root 3 is an element of that set. It turns out it isn't, and if you went according to each of these individually, root 3 is not an element of either one. So overall, I can say that root 3 is not an element of n union q. The other symbol, and this is the final one that has to do with set notation, is this upside down U. It means intersection, and another way to look at it is this term and I'll explain why that is in a minute. But the intersection is where two sets overlap visually. So, for instance, n intersection q is the place where n and q overlap. It's the place that's colored by both of these at the same time, and the only place that is both blue and red, the place that's both overlapped, is this spot here. It's the part that was red, because that red is entirely within the blue. That is the only overlap region. And that means that I can write a statement like this. That overlap region means that this n intersection q is actually completely equal to, it's equivalent to n. That's where those two overlap. They overlap, they both exist in the same place, just where n is. And as another example, if I asked you to find the intersection of z and q prime, integers and irrational numbers, I would look to see where z and q prime overlap, and there is nowhere where they overlap. There's no part of this diagram that's both red and blue. And that means that I can write something like this. This symbol means the empty set. It basically means nothing. There is no overlap between them. And finally, and where the and comes in, is because on, again, pages 3 and I think maybe 4 in your handout, questions like this are asked. Is n a subset of z intersection q, integers intersected with rational numbers? And to figure that out, you can again figure out what this looks like visually, look for the overlap of these two, and see if n is inside it. Or you could ask yourself, is n a subset of z? Is n a subset of q? And when you're dealing with intersection, both have to be true. That's what the and is for. It has to be true here, n has to be a subset of z, and n has to be a subset of q. So if you check them one at a time, n is a subset of both, and because there are two yeses, they are both true, and one is true and the other is true, then the overall answer is yes. And I think this is the final one. If I asked a question like this, is -3 an element of z intersection q prime? I would check both. Is -3 an element of z? Yes, it is. And is -3 an element of q prime? It is not. And that means that -3 is not an element of this intersection. And to show you that that's consistent, if you look for where z and q prime overlap, they don't overlap at all. There is no intersection. So surely -3 is not an element of that intersection. Okay, that is it for lesson 1.